All right, here we go. Chapter 3. We're going back a chapter because we skipped this last semester. Addition and subtraction of equations. We're going to be solving for variables. And the essential question here is, how do you use different strategies to solve one-step addition and subtraction equations? Okay, so we'll start pretty simple. Uh, Again, like some of the other things we've done, you guys tend to look at something that looks real easy and you just kind of guess and check your answer. Let's make sure we get the procedure down how to do this. Okay, so when we start introducing fractions and decimals, you know how to do it. Okay, because you're not going to be able to guess and check those. So what do we mean by an equation? Okay, a sentence stating that two quantities are equal. Equivalent equation. Okay, the left side, x plus 5 equals 12. Okay, and what we're going to end up doing is uh, looking at how to solve for that x. How do we find that number so that that number plus 5 equals 12? Now, most of you can look at that and say, oh, it's 7. Okay, well, that's great, but what if that was 5.2 and this was 126.7? Then all of a sudden you're guessing and checking this. You need a method, and that's what we're going to focus on. Okay, so here's another example of equivalent equations. X plus 3 equals 1, x equals negative 2. It's the same thing because negative 2 right here gives you the 1. What is a one-step equation? Okay, one-step equation is an equation that can be solved using only one mathematical operation to solve for the unknown variable. Okay, t minus 5 equals 7. This is a one-step equation because there's only one operation here, and that's subtraction. Okay, now you're going to find when we solve these, getting into the next thing here, is that we we solve using the opposite operation. It's almost the opposite of PEMDAS. Okay, please excuse my dear Aunt Sally, where you look for parentheses first and you work your way down. Well, here we want to get rid of addition and subtraction first, then we'll get rid of multiplication, division, and so on. So it's PEMDAS in reverse when you look at the whole thing, but we're not quite there yet. So what's the subtraction property of equality? Okay, well, if you subtract the same number from each side of an equation, the two sides remain equal. So if A equals B, and I subtract C from both sides, they're still going to be equal. Okay, an example could be like this. 5 equals 5. If I subtract 2 from both sides, I still get 3. Okay, they're equal because I did the same thing to both sides. It's like a balance scale. Okay, you've seen that before, probably in earlier grades. To balance it, you do the same to both sides. Either you take off the same amount of weight or you add the same weight to both sides. Okay, so how do we use this to solve an equation? All right, well, the example y plus 6 equals 9. The operation here is plus. Okay, so we want to do the opposite. And what's the opposite of addition? Subtraction. So we're going to subtract the 6 from both sides because what we want to do is isolate our variable. We want to get our y, our x, our t, whatever the letter is. We want to get that by itself. Okay, so in order to get y by itself plus 6, you have to subtract 6 from both sides. And as long as you do the same thing to both sides, just like up here, you'll keep your equation equal. Okay, so we subtract 6's here, that cancel out, and 9 minus 6 is 3. So y equals 3 is our solution. And you can always check it by plugging it back in. Put the 3 in for the y. 3 plus 6 equals 9. True. It checks. Okay. Now the addition property is the same thing, only it's in reverse in the sense that if you add something to both sides, the same thing to both sides, they stay equal. If we had a plus 2 and a plus 2 up here, we'd have 7 equals 7. Okay, so how do we use that to solve? R minus 4 equals negative 2. Notice now it's minus. What's the opposite of minus? It's to add. So if I add 4 to both sides, I keep my equality because I did the same to both sides. But my minus 4 plus 4 gives me 0. I'm left with R. There I've isolated my variable again. It's by itself. And negative 2 plus 4 is 2. Is it correct? We'll plug it back in and check. Put the 2 in for R. 2 minus 4 does equal negative 2? Yes, it does. Check. Okay. Let's look at a real world example, a little problem solving. From page 152, example H, a tiger lives 17 years. This is 3 years less than a lion. Write and solve the equation to find the age of the lion. Okay, whatever it is we're looking for, the variable, the unknown variable, we're going to denote it in whatever it happens to represent. So here I'm going to say let L equal the lion's age. Okay, you can use any letter you want. I used L for lion. So we know that the tiger is 17 years, and that is 3 years less than the lion's. So if I took the lion minus 3, that's supposed to equal the tiger's age. Okay, now again, the more we do of these, the more comfortable you'll get on setting them up. So if you're struggling at first, don't worry about it. It'll come back. You'll get it. We've got a minus 3 here with our variable, so we want to add 3 just like we did up here. So that cancels, and then we get 20 equals our L. Does 17 equal 20 minus 3? Sure does. Okay, let's look at another couple of quick examples here. Here we've got a plus. When we see a plus, we think opposite. We're solving for the variable. That cancels out. I get my n. I've isolated it. It's by itself. And 8 minus 6 is 2. Does 2 plus 6 equal 8? Sure does, so it checks. 7 equals y plus 2. I want to get y by itself. I don't care what side it's on. I want to get it by itself. So I've got a plus 2, so I've got to subtract 2 from both sides. Do the same to both sides. Cancels there. And I get 7 minus 2 is 5. Does 7 equal 5 plus 2? Sure does, it checks. Here I've got a minus. I see a minus, I think opposite. I got to add 5 to both sides. Notice I don't care what's on the opposite side. All I care about is what's being done to my variable. Okay? And this is minus, so I do the opposite. So that will cancel. Negative 5 plus 5 is 0. Adding down, x is 11. 11 minus 5 equals 6. It checks. Again, I find my variable. I see that I'm subtracting 6, so I do the opposite. I add 6 to both sides. That cancels out. And negative 1 plus 6 is 5. Does negative 1 equal 5 minus 6? Sure does, it checks. Okay, so we're going to get after this in the next week here, solving one-step equations with addition and subtraction. Okay? And we'll get after that tomorrow.